Okay, so welcome to this presentation of project 8.2, Man in the browser to retrieve content of SSL connections. So first off, originally I had set up a presentation that explained things in better detail and explained more of the background concepts. So originally I had a section that gave a brief overview into x86 assembly, but soon the presentation was approaching 50 minutes, and so I decided to scrap that. So perhaps this presentation might be a bit confusing if you do not already know assembly language, but that there really is no time. So there's also no time to go into detail into a lot of concepts here. So I will only be able to give a brief overview. So the objective of this project was to try to capture data before it is encrypted and sent, specifically data that's sent to a web service that uses HTTPS. So to do this, the goal of the project was to write a tool that gains access to this unencrypted data somehow, and also another bonus objective was that it should be able to capture data from several different browsers. So in order to make things easier, I decided to focus on one browser at the start, but always keeping in mind this bonus objective of trying to make things general. So I selected Mozilla Firefox as the web browser that this program would first be implemented on, as this is the one I'm most familiar with and it's the one I use daily. Another bonus benefit of using Mozilla Firefox is that it is open source, so if I want to inspect some code, this option is available. So the easiest way to gain insight into how Mozilla Firefox handles secure connections is not to inspect the code, I feel, but rather to use analysis tools to inspect Firefox while it's connecting to a secure web service. So the tools that I used for this was mainly WinDebug, which is part of the debugging tools for Windows. This is a very powerful user mode and kernel mode debugger with a lot of functionality, and it allows, for example, to set breakpoints to see process memory at specific instances in time. So the next tool was a tool by Windows internals called Process Explorer, which is sort of a more powerful task manager, as it allows you to see much more in detail what active processes is doing. It was mainly used in this project to just look at loaded DLLs and look at threads. So also another tool by Windows sysinternals is Process Monitor. This is a process activity logging tool that logs registry data, file events, network events, and so on. This was mainly used to just get an overview of the network communication that Firefox would do, as using Wireshark, for example, would be much too detailed into what I was interested in. Finally, I used dumpin. There are several tools that can have much of the same functionality, but dumpin is a simple command line tool, and what it does is that it shows the imports or exports for any given DLL or executable. So this is useful to see what kind of functionality Mozilla Firefox imports from the operating system and other DLLs. So just to go quickly through some background concepts. The first important concept is Windows sockets. The current version is version 2.0, and basically it's used to enable network or rather programmers that wants to write network applications to have an easier time writing network application without having to have a deep understanding of how the network protocols work. So it's quite likely that in some way Mozilla Firefox also uses Windows sockets. So the next background concept is Network Security Services, which is a library developed by Mozilla, and this library provides a lot of functionality that is useful for establishing secure connections over a network. So a lot of the NSS functionality in Mozilla is implemented in Mozilla Firefox in a dynamic library called NSS3DLL. So looking at this library could provide some insights into how Firefox handles secure connections. So next we have Windows Detours, which is a library developed by Microsoft Research in 1999. This library provides functions for intercepting function calls and then send them to a detour into your own code. So what this means is that it can, for example, look at any parameters that is passed to a hooked function. So this can be very useful if one wants to intercept unencrypted data. So when starting analyzing, the import table was dumped for NSS3DLL, and it revealed that NSS imports the send function in the Windows sockets library. So knowing this and knowing that we want to find and dump the unencrypted information that is sent through a browser, this function provided a useful starting point. So seen in this picture is just a picture of how it looks when you use WinDebug to debug Firefox. So here you can see the call stack for the current thread. So when analyzing a secure connection and setting a breakpoint at Windows socket send, this is the call stack that was revealed. So as we can see here, there are only three parameters are revealed on the call stack, although most of these functions have more than 3 parameters. Only 3 are displayed, but you can, for example, just manually dump the memory area around the stack to find all the parameters. But here the most interesting parameter is the middle one, as this is the pointer to the buffer. So in the Windows socket send function, this buffer contains encrypted data, while if we retrace the stack into previous stack frames, we can take a look at this. This is also a buffer. If you look at the documentation for SSL send, you will see that this is also a buffer. And if you look at the contents of this buffer, you will see the unencrypted data. So if we can gain the address of this buffer, then we would be well on our way to find the unencrypted data. Okay, so the program itself is written in Visual Studio 2010, and it's written mostly in C++ and consists of 2 parts. One part is the hook send project, which is the DLL, and the other part is test remote, which is the executable. So to give a basic overview of what the program does is that first the executable will inject a DLL into the web browser. Then the DLL will hook the send function in the Windows sockets library, and by retracing the stack, this will allow the hook routine to find the unencrypted data. The unencrypted data will then be written to disk in a log file. So to inject the DLL, the executable uses a well-known method that first creates a remote thread, and this remote thread will then execute the load library routine that will load the desired DLL into the process. The DLL will then continue, will perform the hooking and interception of the necessary function. So the hook routine is written in assembly language for convenience, and as explained previously, it will retrace the stack and then write the contents of this unencrypted buffer to a log file. So when running the program, you will be greeted by this welcome screen, which will allow you to enumerate processes, set the path variable, attempt hooking, or quit the program. So if you first try to enumerate the processes, you will be given a list of the active processes along with their process ID. This makes it easier to select the process ID of the process that you want to hook. So here you can see a successful DLL injection of Mozilla Firefox. So then the DLL will continue the execution, and hopefully it will save any user data that gets sent and store them in an unencrypted format. So that was really all. Sorry I did not get time to go into more detail, and it's a very brief overview, but that's all I had time for. So thank you for today.